Okay everyone, this is part 3, the final part of me coding a simple production style C++ application for Windows. I'm using Win32 and the application is doing a task of removing a digital signature from a PE binary file. Okay, so in the previous parts we pretty much coded everything. We coded this function that removes the digital signature, and right now we just have to do a couple cosmetic tasks to actually put it into our main so that something actually is called. So let's do it now. Now we will assume that our application, which is a console app, is taking command line parameters. They will be very simple, and so let's check for that. Do we have a command line? Now if you know, the way main function is called is that this is the number of parameters, and the first one is always the executable itself. So if we have more than one, now for instance if I put a breakpoint here and if I run it, you would see that this is 1, and the first parameter is just the executable. So we are not interested in that. If that happens, we need to output just basic information about our application. So we can just say no command line, and just use basic printf, and I'm going to break it up into lines like this. Now first of all I need to remember to return 0. 0 in Windows terminology means success. In this case, in the case of a process, so we return 0, means no error. And let's do, like, first we have to output our app name. Now again, I'm not going to hard code it here. I'm going to take it from the shared H file, and then we need to output our file version. Again, I have it here. So okay, that will do. Okay, usually production app has copyright message, and then we have year, which we'll supply later, and then by. In my case I just provide myself, my company here. And now usually, just to make it more user-friendly, I would say how to get more information, use H command line switch, not stitch but switch, for more info. Okay, so that will give users some basic information how to expand, how to get more command line parameters. And we also need to provide a year. What usually happens is that when you do a copyright message like this, let's say if I wrote it in the year 2021, it should just say this. But if it's year after 2021, if it's like, you know, I don't know, 2025, it should say this. So basically it's kind of like saying that, hey, that's the beginning year and that's the year it is now. That's what I kind of like doing in my production apps, but we have to do it dynamically. That's why I put the placeholder here that we will have to calculate here. So we need a small buffer for the year. It shouldn't be anything large, just 32 enough on the stack. And then we need to get current time. I usually like using get system time, which never fails. It always returns system time. Let's zero it out just in case, and returns it as such. And let's say that the year, the start year, is this year when I'm coding it. Okay, and then we see if the year today, let's say year, is less than equal our start year. I'm doing less than equal in case the person that in case they change the time and it's like something like 1980, you know, so it will be before the start year. So in this case we are using just that year. I'm using again safe printf available, that's available from Windows, that takes actual count of the buffer. And then as my year specifier, I just say, okay, I need a 4-digit year. And what I'm doing is just doing the start year. Oops, let's put space. And just for the heck of it, to make sure that this works, I'm going to verify that it succeeded and put enough quotes here. Okay. Now, in case the year is after the year 2021, I'm specifying, oops, not like this. I'm specifying 2 years. In this case, the first one is the start year, and the second one is the current year. Okay. And then at the end, what I'm doing, I'm just including it over here. Okay. So now we can build it and actually test it. So what will happen is that it gave us just this year today, which is correct, gave us the version and the name, and it told us how to retrieve more information. Now, just to show you what happens, let's say if the creation year was like 2020, last year, so it will output like this. So 2022, today's year. So again, this is just a little trick that you can use. But anyway, this is like not very interesting example. The interesting one is when we actually have a command line. So in this case, we need to go through, let's see, through command line parameters. So what we do, I'll just call it P. The important thing is to start it from index 1 and go to, oops, go to the last argument that we have. Okay. Now I usually, just for debugging, I separate it from this weird array pointer of arrays as such, so I can actually check it. And then I check if we need it, because you know there might be quite a few command line parameters in the future, so we need to go through them. Now here most people just go and simply code it, you know, like if this equals to P or I or whatever. But I personally prefer to write a little helper method that will make me like discern which parameters, because what we can actually have, like what I'm thinking is that the command line parameter will be file and then like the file itself. But the user should technically be able to specify something like this or something like this or something like this, you know. It all should be acceptable, you know, like the case shouldn't matter, or if it's a slash, backward slash, forward slash, or the dash. So all of this should be acceptable. It's just for usability. So let's write a little helper method. I'm gonna go to my class, and the helper method will return a boolean, and it will be called is command line param. So what it does, it will take, let's say it will take a command that was passed to us, and it will also take command to check. And we have to write what it does. It will return true if command to check is this command line parameter, case insensitive. That's insensitive. Okay, now before we can do anything with it, we need to add a declaration. This is a static, and this is actually a public one that we can use from the outside. Okay, so now let's use the logic in it. First of all, we will return false if our checks don't work out. So we need to make sure that the user actually, or the caller actually provided something. And that's how we do it. So we make sure that the string is not null and it actually has something. Then just a little bit of a sanity check. The command must start with a letter only. Okay, so this is to make sure that this command to check starts with something sensible. So let's just do a quick check. So make sure that this is letter. Z. So it has to be some alphabetic letter, because that's how commands are, or it has to be a capital letter, or kind of like one exception from this rule, it can be a question mark for help. So this is just a sanity check. It doesn't go into production. It's just we just make sure that whatever command we have, we format it correctly. Okay, well, and then we just do a check. So we get the first symbol from the command line that was passed by the user, and then we see is Z if our thing is, well, dash, if it's a slash, or if it's a /. All of it is acceptable. And then we need to compare string. Now, compare string is an API in Windows, and you can search for it in MSDN, but basically we're going to tell it that we are using the default locale. We would ignore case without any fancy bells and whistles there. Now then we will take the next character after these, and we don't know the length, and we need to compare it with what we want to compare here, and we don't know the length of that either. So if that equals string equal, that will return true. Okay, so this is our little helper method that will help us determine if our parameter is in any of these formats, plus we will ignore case. Okay, so this will help us here in our actual main to check if for specific parameters. So then we can just do command param, and in this case we need F, and if that matches, we get it. And then we have another one. And lastly, we have let's see if I can spell it, unsupported parameter. Okay, now in this case we also need to be able to call our report error. We don't know with what error code, but we know the actual user message. So we would say unsupported command line parameter, and let's provide which one so that the user can tell. Use question mark for more info. This is again just something to help user to identify the problem, and it tells them like, hey, this is not supported, and it will show which one is not supported, and it will say, okay, use this parameter to actually show an error. Now before we can forget, let's provide a handler or a case for this situation. In this case it's a question mark, or sometimes it can be H for help. So in this case we will show help, and right here we need to find the error that we will return back. Again, for that let's use WinAPI search, and in this case let's just search for command, and well, there's a lot. Well, how about this not recognized command that says device, but that's okay. So if we do this and just use 22, that will give us a error code for unsupported command. Now what we also need to do, we need to break from our loop so that we don't just keep going. If we found unsupported command, that means there's an error. and the procedure will return general failure. Now, before we even go any further, let's create the help. The thing with the help, though, once we find it, we need to return 0 for success and return and break the loop. Okay, now the help, we would also go into our class with all the implementation, and let's write it. Let's just show, let's say, call it show help info. The show help info is just a function that outputs help information. Let's create a declaration for it. It has to be public. That is correct. Okay, and let's just say what it does. Show help info to the console. Just very simple. And we will just do simple printf. I'm using the wide version of it. And let's just do just the way like pretty much all applications do this. So it's like information on each new line. And first will be the process name. Now you can technically hard code it as SigRemover, but I will not do this in production. I would actually calculate it, so I'm going to use placeholder. Then we're going to use our F command line parameter. And here let's just say PE file. Right, so let's skip one line and then let's say where, and then specify on the next line. Let's see, PE file. Let's see, PE file to remove signature from, and then let's say a new file will be created if success. Okay, so that the user know that the file will not be overwritten. Then let's skip one line and let's say example. And on the next line, again, we're going to use placeholder for our process name. And then in quotes, to show that the user has to, rather put something in quotes. And file exe, and one last end line at the end. Okay, and then let's put our placeholders here. Let's fill them in. So again, you can technically put SigRemover in here without doing any fancy stuff, but I like to calculate which process am I running in. Let's say get current exe file name, and also we don't need extension, without extension. And let's see, buffer, let's say buffer this, and let's just go with default max path. Let's zero it out, and let's get the module file name where we are running. For that we'll pass null, and we're gonna do buff this and provide count of. Just gonna copy and paste. Okay, so then we need to find extension and buff this and remove it. This API will always return a pointer within this buffer. And then we actually need this file, which we can find file name and buff this, and then we can use this file for this placeholder, and also that same thing for the second placeholder. Yeah, that's pretty much all we need. So at this point we can call our help from here. Okay, before we go any further, let's just test this real quick. Make sure it compiles, that there is no warnings. Let's run it. Now without any switches, it just doesn't do anything. Now let's provide a command switch. Now if we go into debugging and do, let's say help, let's do the H capital. So this will give us a little help file that we just created. So it's kind of like, you know, for the user to be able to see how to call the app. So right now all we have left is just to implement this F switch. Now the interesting thing is that it's not just the F switch itself, it takes the next parameter that follows as the path. So, and we have to account for it here. So we need to see that we need to say must have the following file path. Now how do we know this? Well, we just simply say if p + 1 is less than arg c, then we can go ahead, otherwise it's an error. Now we can just reuse the same format here, because technically it's a bad command line. And what we can say here, and probably don't need this, is that f command line parameter requires a file path. So this basically means that you can't just use f by itself, it requires a file path. Okay, well, in this case we actually have the file path as the next parameter, and then we can just say remove binary I always have a problem spelling signature for some reason, from the file. Okay, and what we can do, we can actually use our remove digital signature, and what we can do, we can actually use the next parameter. Okay, and since our function returns our exit code, I can just do that by casting it to int. So at this point we can technically build it. Now right now we're still showing you know, help, but first let's test it with a bad command line parameters. Let's say some file.exe, which doesn't exist. So if we call it this way, let's remove breakpoint and run it. Oops, not run it, let's just do this. And here we go. We get actually an error which says fail to open binary file, some file, and then we get the Windows error, which is error number 2. The system cannot find the file specified. Moreover, if we actually run it in the debugger, we see that the exit code is -2. Now -2 is kind of confusing because it's also failed to open in our case. Now I promise I didn't try to match it to the error code in Windows, but this is how you can tell that this is a problem. So someone, by running this executable, the SigRemover.exe, can check the error code, and if it's anything that's 0 or 1, 1 means no signature, they can actually tell kind of like generally what the problem is. Now for more detailed outcome, they have to check the actual console output, and in this case it would be this. Now you can technically create special, you can use a special error output here, so that it goes into standard error instead of just general console, but I will not worry about this here. Okay, well now it's actually a good test to see if we can remove signature. So as you can see, again, the signature is valid on this file. Let's make sure, let's close this. Let's make sure that it runs, and it does. So first let's get its path. So remember our command parameter is this, plus we have to specify quotes and the actual file name, and we need extension. Okay, so let's put a breakpoint over here, run. You can see we have several arguments. we go in, here's the command line, which is -F. We recognized it here. We have enough parameters. And let's see if this works. Error code is 0, which tells us that, hey, success creating new binary file without signature. It gave us the new name, put it in the same directory. And if we keep going, our process exits with the exit code 0. Let's take a look. So here we go. We have a new file which has no sig name. If we look into it, as you can see, the signature is gone, and we can run it. So there's no problem with it. Now additionally, if we run it again, you can see it does again the same thing, and it actually says, hey, it overrode it quite nicely. So, and the last test, if we remove it as such, so like if original file didn't have any signature, if we run it, it tells us that binary file has no digital signature. And if we run it through a debugger, we see that the error code is 1, which basically means that our file has no binary signature. Okay, so at this point we can build, for instance, release file, release configuration to make sure that it all builds correctly. Before we do this though, let's change something. Let's go into properties and remove our test here, because you know we don't want to overwrite files. Again, go to release, build it, and if we go SigRemover, release, so here's our file, just 17 kilobytes, runs just fine. So if we just run it in the console, provides just basic output. We can just do H, and it gives us our information. So, and then if we go into property, it actually has our information, tells us what the thing is, it has our copyright, and pretty much everything else. So at this point, I will stop, because again, this is just the minimum application, kind of like production style application that shows proper error handling and proper output to the user, also all the proper safety checks of buffers and other overruns. And I will post this app as a binary on my website and also as a source code on the GitHub. So if you guys are interested to see more of these things, let me know. I can, create maybe a more complex application, or maybe do something else, maybe GUI app, or maybe do something with the cross-platform C++. But anyway, thank you for watching, and see you next time.